In intermediate first year, we'll have one more long questions to get from oscillation chapter. There are two important questions in oscillation chapter. After that, we will see one question now. That question means show that the motion of simple pendulum is simple harmonic and hence derive an equation for its time period. And what is seconds pendulum? Okay, now this is the question. Show that the motion of simple pendulum is simple harmonic and hence derive an equation for its time period. What is seconds pendulum? Okay, now we'll see the answer for this question. Now in order to discuss the answer for this question, let us consider a simple pendulum. Now this is a metal bob. We call it as a simple pendulum, which is suspended from a rigid support, such that from rigid support to the center of the pendulum is called length of the pendulum, and here it is fixed at point O. Okay, now let us suppose that the mass of the pendulum is say m and length of the pendulum is say L. Then when it is dragged to one side like this and left it to itself, then it will make oscillations from point B towards A and goes towards the other side. So it is the to and fro motion of the metal bob which makes oscillations. Oscillation nothing but if we drag the simple pendulum towards an extreme position like B, then if we release it, then it moves or oscillate towards this side, other side through the mean position, and again it comes to the same point B. Then we say that there is a one oscillation is completed. So for this oscillation to take to complete, there will be a time taken, and that time taken to complete one oscillation is called time period, which is denoted by capital T. ఓకే, ఒక పెండులంని ఈ విధంగా ఒక ఫిక్స్డ్ పాయింట్ దగ్గర ఫిక్స్ చేసినాం. దీన్ని ఇక్కడ నుంచి సెంటర్ ఆఫ్ ద పెండులంకి లెంత్ ఎల్ అని అనుకుంటున్నాం. ఈ పెండులం మీన్ పొజిషన్ నుంచి ఒక ఎక్స్ట్రీమ్ పొజిషన్ బి వరకు డ్రాగ్ చేసి వదిలేస్తే ఇది ఆసిలేషన్ చేయడం స్టార్ట్ చేస్తుంది. ఆసిలేషన్ అంటే బి పాయింట్ నుంచి వదిలేస్తే అది ఇటువైపు వచ్చి మళ్ళీ ఇక్కడ దాకా వస్తే దాన్ని ఒక ఆసిలేషన్ అంటాం. ఈ ఒక్క ఆసిలేషన్ కంప్లీట్ చేయడానికి అది కొద్దిగా టైం తీసుకుంటుంది. ఆ తీసుకునే టైంని టైం పీరియడ్ క్యాపిటల్ టీ అని అంటాం. ఎట్ దిస్ పర్టికులర్ మూమెంట్ ఇట్ ఈస్ ద డిస్ప్లేస్మెంట్ ఫ్రమ్ ఇట్స్ మీన్ పొజిషన్, which we denote it as a theta. Okay, angle theta. Now the weight of this metal bob is divided into two components. Weight nothing but mg, w is equal to mg. This weight is divided into two components. One is mg sin theta, this is mg sin theta, and the other is mg cos theta. Okay, weight which is acting vertically downwards, it is divided into two components, mg sin theta and mg cos theta. Okay, ఇప్పుడు ఈ మీన్ పొజిషన్ నుంచి ఎక్స్ట్రీమ్ పొజిషన్కి డ్రాగ్ చేసినప్పుడు that pendulum automatically will come to its mean position. That is because of restoring force which is produced in it, that restoring force is denoted by capital F. ఓకే, మీన్ పొజిషన్ నుంచి ఈ పెండులంని ఇటు డ్రాగ్ చేసినప్పుడు అది ఆటోమేటికల్లీ మళ్ళీ ఎటువంటి ఫోర్స్ అప్లై చేయకుండానే మళ్ళీ మీన్ పొజిషన్కి వస్తుంది. ఆ మీన్ పొజిషన్లోకి మళ్ళీ రావడానికి రెస్పాన్సిబుల్ ఎవరు అంటే a force, new type of force is created in the simple pendulum, that is called restoring force. Okay, here for the string there will be a tension which is acting towards the fixed point, and exactly in opposite direction there is another force which is acting mg cos theta. So both are in opposite to each other, therefore they cancel with each other. Here only one force is left, which is mg sin theta. That mg sin theta is always equal to restoring force. Therefore we can write restoring force F as mg sin theta. Okay, ఇక్కడ ఫోర్టీస్ అయిన రీస్టోరింగ్ ఫోర్స్ని ఎంజీ సైన్ టీటాకి ఈక్వల్ అని రాస్తున్నాం. సో ఇది రీస్టోరింగ్ ఫోర్స్ కాబట్టి విచ్ ఈస్ ఇన్ ఆపోజిట్ డైరెక్షన్, దేర్ ఫోర్ వి రైట్ మైనస్ ఫర్ ఎంజీ సైన్ టీటా. సో ఎఫ్ ఈజ్ ఈక్వల్ టు మైనస్ ఎంజీ సైన్ టీటా. ఓకే, బట్ ఫ్రమ్ అకార్డింగ్ టు న్యూటన్స్ second law we have F is equal to ma. Okay, if we substitute this value F is equal to ma in this equation, then ma is equal to minus mg sin theta will get. Okay, now here m will get cancelled with each other, then a is equal to, we write minus mg sin theta, sorry, minus g sin theta. After m gets cancelled, we will have a is equal to minus g sin theta. Let us say equation number 1. Okay, if this theta is very very small, then this sin theta can be taken as approximately equal to theta. Then we will write a is equal to minus g theta. In place of sin theta we will write only theta. So a is equal to minus g into theta. Okay, now we got a is equal to minus g theta. Then name it as, say, equation number 2. Okay, now if you see this diagram, if you imagine a circle like this, then this is the center of the circle, this is the center of the circle. Then we have, this is the angular displacement. Now this is nothing but arc for the circle. Then this is the radius of the circle. So radius of the circle is equal to L. Then arc is equal to x. Then if you imagine a circle like this, we can write angular displacement theta is equal to x by L. Okay, x by L. Now say this equation number 3. So theta is equal to x by L. From equation 3 substitute in equation 2. Now substitute equation 3 in equation 2. We'll get a is equal to minus g into, in place of theta just substitute x by L. Okay, so a is equal to minus g into x by L, or we can write this as a is equal to minus of g by L into x. Okay, g by L into x, or else we can write this equation as a proportional to minus x. Okay, a proportional to minus x, say equation number 4. What this equation indicates? A indicates acceleration, x indicates displacement. So acceleration is directly proportional to displacement and is opposite to the displacement. So which is the condition to be satisfied in order to say a object is in simple harmonic motion. Therefore we got here a proportional to minus x. So we can say that the motion of simple pendulum is simple harmonic. Okay, ఇక్కడ మనం ఇది డ్రాగ్ చేసినప్పుడు యాక్సిలరేషన్ మీన్ వైపు ఉంటుంది, మీన్ పొజిషన్ వైపు, బట్ డిస్ప్లేస్మెంట్ ఆపోజిట్ డైరెక్షన్లో ఉంది. సో యాక్సిలరేషన్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ఎక్స్ అంటున్నాం. ఓకే, but it is in opposite direction. So acceleration is towards mean position, but displacement is towards extreme position, so both are in opposite direction but directly proportional to each other. So condition is satisfied, so we say that the motion of simple pendulum is simple harmonic. Okay, now in the second part of the question we have an equation or derivation for time period capital T. ఓకే, డెరివేషన్ ఉంది. దీనికోసం మనం సపోజ్ ఇఫ్ వి సపోజ్ దట్ ఒమేగా ఇస్ ద యాంగులర్ వెలాసిటీ. ఇఫ్ an object is rotating in a circular path, we take velocity as angular velocity. That angular velocity is denoted by omega. Then if omega is the angular velocity, then its acceleration will become a is equal to minus omega square x. Okay, a is equal to minus omega square x. Say equation number 5. Okay, equation number 5. And here we have a is equal to minus omega square x in equation number 5, and here we have a is equal to minus g by L into x here. So if LHS are equal, we can equate RHS. If we equate RHS, then minus omega square x from here, and then minus g by L into x, g by L into x. Okay, if we equate the RHS, then both the sides minus minus will cancel with each other, then x will get cancelled with each other, then what is the remaining? Omega square is equal to g by L. Or else if we square root comes this side, then omega is equal to under root of g by L. Okay, omega is equal to under root of g by L. And after getting omega is equal to under root of g by L, we got or we have a formula for time period. T is equal to 2 pi by omega. Okay, and if you write here 2 pi by in place of omega, if we write g by L, then we can write here as 2 pi into root of L by g, which is the equation for time period of oscillation of a simple pendulum. So capital T is equal to 2 pi into root of L by g, where L is the length of the pendulum, g is the acceleration due to gravity, and T is the time period. Okay, now in the question we have a third part, which is what do you mean by seconds pendulum? Okay, a very simple definition: a pendulum whose time period or a pendulum with time period of 2 seconds, is called seconds pendulum. Okay, now this is the answer. Okay, thank you.